Go ahead, Shambhavi.
Right. Hello, everyone. Today we have with us Amit Moryossef. He is an intern at Google Zurich and a PhD student at Bar-Ilan University. His research interests include sign language processing, and today we are going to discuss a publication by him at ECCV 2020 based on sign language itself. The publication is real-time sign language detection using human pose estimation. We look forward to your talk.
Great. Hi. Thank you for the introduction. Yeah, so as you said, today I'm going to talk about this publication that we made called Real-Time Sign Language Detection Using Human Pose Estimation. But first, I want to just say a few words about myself. I am a PhD student working on sign language processing. And right now I'm still an intern in Google Zurich. I'm active on Twitter, so if you want to chat me, hit me up there. And I have a YouTube channel where I try to kind of document my research and keep that going for the future. I want to say a bit about sign language processing before we get started with the actual paper. So one misconception that exists is that sign language exists just one sign language, and that is not true. There are many sign languages. Sign language is mainly because of geographic location, and it depends on geographic location. And so we have the sign language basically everywhere, and not only one sign language even per location. So for example, Swiss German sign language, you'll have 5 different dialects depending on the sign language deaf school that someone attended, or American Sign Language is also different between regions in the United States. And in Israel, a small country, we have 7 different sign languages with a different number of signers. There are many, many sign language families. I know this is very small. This is just to illustrate that there are a lot of them. And roughly about 200 sign languages that are currently actively being used. The sign language processing field is somehow a hybrid of the NLP, natural language processing, and the computer vision fields, because it is a language that is conveyed visually. So if you look at the person to the right, she is signing right now in American Sign Language, "How are you?" And that needs to be first understood in a computer vision kind of way. So understand where's the woman, what is she doing? But also needs to understand in a language kind of way, because she might be signing concepts that are not just straight up English, and are not straight up English. Like sign language is a different language than the counterpart spoken or written language. I want to show a quick example of how like sign language or American Sign Language in this example looks like. I'll just show this video here, where you can see a few women just signing, and they can sign simultaneously. The woman on top left is signing, the woman on the bottom right, and maybe the woman on the bottom left might join. And this is how it normally looks like. There is no audio, so like even though I muted here, there is no audio that I can hear. It's just a language that is conveyed visually.
Got it.
So today I want to actually talk about this publication. As I said before, it was published as a long paper in the SLRTP 2020 workshop, as well as, oh, I should do a full screen here. My bad. And present. Yeah, sorry about that. Yeah, so so we have it presented as a long paper in the SLRTP workshop and as a demo in ECCV. It's a shared work. Ioannis Strenouris from Google, Ria Aroni also from Google, Sarah Ebling from the University of Zurich, and Srini Narayanan from Google. So let's talk a bit about what is sign language and what are the problems that signers currently do have right now. Right now in video conferencing applications like this one, like we're now using Zoom for this webinar, the application detects who is speaking by their voice. So if I am speaking and my microphone volume is above like 50%, Zoom will say, okay, this person is now speaking. This helps in like turn taking and helps me get noticed when I try to make a point. And also helps me notice who else is talking. It also is really important when you have many participants in a call and some of them might be hidden. And once they are talking, they might just come back to the conversation. So one previous work about this was done by Borg and Kaderi. They worked on sign language detection kind of in a wild data set where they have YouTube videos and they want to detect where in the video sign language is being used or spoken language is being used just by the video signal. And they have like an offline method that works pretty slowly, but works in a very high accuracy given the entire context, which is good to actually manage to segment where is signing and where is speaking content exists. But in this work, we actually wanted to design a real-time sign language model. So something that can work as video frames come and works really, really fast, does not have to wait, I don't know, like the other work, 3 seconds per inference. And we also said, let's take one more step and actually make this usable. So we built an application that allows you to use this sign language detection model, and applications like Zoom or Google Meet or others might just pick up on a signal and then they will know that you are signing right now. So in order to do that, we had to find some kind of data of people signing and not signing, where we know where and when they are signing in which frames. Luckily for us, there is a data set called the public DGS corpus. DGS stands for German Sign Language. And it contains long videos of people signing in like conversations, so like 10 minutes per video. It comes pre-processed with pose estimation. So as you can see on the image to the right, you have like a photo of a person, and then you can see every limb of their body, every joint kind of tagged. And the important thing is that it includes span annotation, where it says this person is now signing these words. We don't really care right now in this work about which words are being signed, but we do care that in this kind of span, there is signing, and in another span, there isn't signing. One thing that it contains, although in like a smaller subset, is some kind of distractors. So where people, for example, like I am right now, swiveling in the chair, but they aren't signing, or when someone scratches their face or just holding their hand like this and swiveling in the chair, while scratching the face might be signing. For example, in Israeli Sign Language, this is pink. We don't really want to catch all these cases. So it's important that this data set does include some distractors. And one idea, or our main idea, was that sign language is, when sign language happens, movement happens. Not necessarily the other way around. So when movement happens doesn't necessarily mean sign language, but when sign language happens, movement happens. So if we can detect what movement pattern exists, then we might be able to detect whether sign language is being used or not. This is also just the language of the body. So the language doesn't care what happens in the background. The background can be virtual, like I am using right now, for all we care, or it can be moving. That's fine. The background does not mean that someone is using sign language or not. So a naive solution, or what we came up with really quickly, was saying if we have frames of a video here from left to right, and we want to know whether they are using sign language or not, we can first take the pose estimation, which means that instead of using the full image data, we can now work only with a few set of landmarks. So that set changes. I'll show more in advanced, but show more in the future. But it is a very small subset, which means that any processing that we'll do on top of that will be quite fast. The processing that we decide to do is called optical flow, where we take these subset of points and we kind of ask for each point, how much did it move from one frame to another? Or by how much time, meaning that if I do like a wave, the joint moved from here to here in, I don't know, 3 frames, and in every frame it just moved a few centimeters, and that's being checked or caught. Then we say, why not just feed that into an LSTM that is aware of the context of the full history? And if we have 10 minutes of video, that's okay. We have to do only one computation per new frame, and it will understand the entire history, or hopefully understand the entire history, depending on what the LSTM manages to capture. And finally, we can just classify, is this person signing or not, using a standard MLP or just a linear layer. We did some experiments by checking different kind of subsets of points that we'll do the optical flow on. We started with pose all, which is a set of all pose information that we're getting from the DGS corpus. This is a very extensive data, and hopefully in every application we'll have all this data. But acquiring this data is very, very costly. So acquiring this data requires to first do like a body pose estimation, and then do hand pose estimation for both hands, and also the face estimation. We wanted to see if we can go cheaper computationally and just use the body pose data, or only use just the body hands data, the pose hands data, sorry. And finally, even thinking about models like YOLO 5, which can do like 150 frames per second bounding box detection. What about only using the bounding box of the hands, the face, and the body, which will be much faster to acquire? The optical flow, yeah, please.
Yeah, go ahead.
Yeah, from the slide itself, I understand that we are discussing computational needs here because the model needs to be deployed in real-time action. But if deployment is not the focus at the moment, would it not be a better idea to use a combination of pose all, pose body, pose hands, and bounding boxes and image hand segmentation from the image in a like model mixture or ensemble learning kind of a way? Wouldn't it be a more robust way to detect the gesture?
That's a good question. So right now, the pose all, or yeah, the pose all is kind of a superset of all other features. So pose all does include the body, it includes the hands, and it kind of also includes the bounding boxes by just having the poses. So the pose itself kind of identifies where the bounding box starts and ends. Like if we'd like to conceptually think about, for example, the face, the model can learn that this kind of point at the top left, and maybe the X and Y of these points kind of set up the bounding box. Using them separately and having like an ensemble model could actually work quite nicely, especially by being robust to different types of mistakes. This is not something we tested because we were, I guess, under the impression that the first representation, the pose all, kind of includes everything, and then we're just removing features from there. Yes. But it is a good question and something that is worth exploring.
Yeah, right. Because like the data set here has been already curated and is very well constructed, the German sign language data set. But when we are trying to create our own data set and we are using something like open pose on the videos, it actually misses out detection in a few frames.
Yeah.
So
yeah, so that's also something that's worth considering. So for example, if we can't catch the hands, for example, in certain frames, or right now you can't see my hands when I'm speaking, or you can't even see my elbows, what do we do? Like how does this going to work for these cases? Or even if I'm exactly moving like really fast, the models often don't detect the hand very well. In this corpus specifically, the videos are very high quality and high frame rate. So they're like at 50 frames per second, meaning that OpenPose normally manages to catch the poses pretty well. And if not, then we hope that our model manages to kind of cover up for its mistakes. So learn what seems like a mistake and figure out how to correct it. Yeah. So in all actuality, the model sees something like this. So this is how it looks like for the model. This is the optical flow of every frame in like 30 seconds. So this is like 1500 frames optical flow, where we have the optical flow of the body, face, left hand, and right hand. And also in the bottom, we have the yellow marking. I'm not sure if you're actually seeing the yellow because it's quite bright. It means that the person is signing right now. And the purple means that they are not signing right now. We can see that just with our eyes, right? That when there is a lot of movement happening, so the bluish areas, they correspond really well to the signing detection or the signing annotation. And when there is no much movement, there isn't signing. One extra thing that we can notice here is that our data set is not perfect in a sense that here you can see that the signing annotation starts maybe 1 second before the person actually starts signing. And here, the annotation finishes 1 second before the person finishes signing. So it's not quite perfect, and we can't aspire to get 100% accuracy on this data set, because even 100% data set accuracy on this data set doesn't mean that we're doing amazingly well because of these mistakes in the annotation. Looking just at this data, the optical flow, we were very optimistic towards the capabilities of the model, because if we can see with our own eyes that when movement happens, like there is annotation of signing, it means that the model might be able to capture that as well, or even better than our human eyes. For baseline models, we decided to say, okay, when movement happens, that means that signing happens. Let's just look at a linear model, just looking at the current like optical flow between two frames and asking, is the person signing right now? And this is a very basic like movement detector. Was there movement in this frame? Yes or no? We tried to extend this baseline to have some more context. So this is just an example called linear 2, where it takes the optical flow from the two last optical flows that it gets. So it has a bit more context. And we experimented with having 25 frames of context or 50 frames of context. This is actually somewhat faster computationally to just take 50 frames even and feed them into a neural model rather than doing the LSTM, because of all the gates that it has, and it has to have multiple computations one after the other. And this all happens in parallel. But in general, both approaches are quite fast. If we want to look at the results of this model, so we have the three baselines that we tried in the top, linear 1, linear 25, and linear 50. We can see that they use like very low number of parameters in these models, and that the test accuracy is quite high. So we can see that even just looking at a single frame, we're getting almost 80% like test accuracy, knowing if sign language did happen or not. And using more context works until a point. So if we had 25 frames, like we're getting almost 84%, but if we're adding 50 frames, that's like 83.4. And these models are really, really fast. So if we look, if we use sklearn, for example, we get 6 microseconds for the computation for each model, for each new frame. That means that for every frame, we need to wait like 0.000006 seconds of computation on like CPU, which is really fast. We then tested our other models. So we had the bounding box model, the pose hands model, the pose body model, and the pose all models, which are, I'll remind you, is just like taking the pose estimation, optical flow, and then having an LSTM model on top of that with a single layer. And that shows really promising results as well. Just using like bounding boxes, we get 87.7%. Adding the hands, so like a full hands joints, gets to 88%. Having only the body though, just without the hands and the face, just the body, we're getting 90.3%. And having everything, we're getting like 91.5% accuracy. That means, to me at least, that using the entire body is more important than using the hands themselves. But that might be because, as mentioned before, the hands might not be detected very well in every frame. So they might be like dropouts of hands. And so the model doesn't know what to detect because it doesn't see any hands and the optical flow is 0. These models are also quite fast, faster in some frameworks rather than the others. So for example, in TensorFlow, we're getting like 3.5 milliseconds per inference, which is 3.5 thousandths of a second per frame. But this could be optimized because we see like in PyTorch, for example, we're getting like the slowest one is almost 600 microseconds, which is, I don't know, 7 times as fast or 6 times as fast or 6 times faster, sorry, than the TensorFlow model. So there is room for improvement for smaller and slower devices where we really want this to run as fast as possible without hitting the battery and CPU too much. Now that we have a working model, working to some extent, 90% accuracy, we don't really know what it does. We just know it's like 90%, and it's really fast. We wanted to build an application that made this model run, but run for a user for all video conferencing applications. That means that we don't want to wait for Zoom to actually integrate sign language detection in their platform, or Microsoft Teams or others. We just wanted the signer, the deaf person in this case, to have full control over which app they're going to use and have this working for them in all applications. What we do is pretty simple, I guess. We take the user's camera and microphone feed. For the camera, we do pose estimation in the browser. So we use like a TensorFlow JS for this, which is quite fast depending on which model we select, which has different backbones like MobileNet, which is really fast, and ResNet, which is slower. We calculate the optical flow we get from these poses, which is quite an easy calculation. It's just like subtracting 2 frames one from the other and getting their L2 norm. We then feed this to like the next state of the LSTM, which is 1 cell of LSTM calculation per frame. And if the person is detected as signing, here's our trick. We kind of generate ultrasonic audio. So we generate audio that is inaudible to humans at 20,000 hertz. And we kind of forward this audio through a virtual microphone to the user's system. And now Google Meet, Zoom, FaceTime, Microsoft Teams, etc. detect, oh, there is a lot of noise coming from this microphone. This person must be speaking, but the person isn't speaking. They are signing. We're just blasting audio that no one can hear, except for the apps themselves, like asking, is there volume here? And the answer is yes, there is a lot of volume that we're sending. So this is like very a cool trick to get this working.
Yeah. Really interesting, yes.
Yeah, thanks. So I want to show you this in action. We have a demo video because I can't show you the application right now. It's not public.
Understood. Understood.
Let me just full screen this, and I'm going to show this twice.
Okay.
If I can pause this, I'll show it twice. Once I'll explain what's happening, and the other time I'll just let you watch. So this is Mayan. She's a friend of mine. She's an Israeli Sign Language interpreter. when she starts signing, you will see like some indication in the top left in the yellow box there going
Yes,
up.
yes, yes. Yes.
So that's what you can see right now when she started signing. When she
Mhm.
stops, you can see it like goes down. And this is our
Mhm.
detection. If it goes above 50, we say she's signing. If it goes below 50, we say she isn't signing. And as you can see, when she is signing, she says like the software kind of like catches her signing and transmits them. So I'm just going to let you watch this video one more time. I guess I did it in 2x speed, my bad. But one more time and without me talking over it, and hope that you'll understand what I mean by that.
Very cool. And what is the blue trace at the top left corner? Blue
Oh,
trace?
that's the FPS. So because this camera is actually 30 FPS, so it's like capped at 30. It's working as fast as the camera. You see, we have a question in chat.
Yeah.
Has lip movement been used in this model? So yes and no. Let me just close and represent. We can see that one scenario, we have the full face pose as well, including the lips. So in pose all model, the lips might have been used by the model in order to capture the movement or to capture whether the person is signing or not. We do get like 1% test accuracy over not using that. So that might be one of the contributing factors. We didn't try to do ablation only for the face. So we could have also added like a model face only, where lip movement is being used. And so we could check this, but this is not something we tested. I'm kind of curious to test this right now, but yeah, but to answer your question, maybe it's been used only for the pose all model.
Yeah. Geetanjali, does that answer your question? You can unmute yourself and go ahead if you have any follow-up questions.
Yeah, please.
Okay. Yeah. I had one question.
Please.
You have used a German data set, right? German sign language data set. But in the video, it was Israeli
Yeah,
sign
yeah,
language, right?
correct. Yeah.
So any difference? Did you notice any difference? Or?
Yeah, so first I'll say that linguists, like sign language linguists, kind of somewhat believe that the Israeli sign language is like a child language or like a predecessor, no, ancestor.
Like,
The other one.
okay.
It's like a child of
Yeah.
German sign language.
Understood.
So that might have an effect, but we don't see an effect even using American sign language. This model that we have is only doing like body movements. Body movements are shared between all sign languages. They have like limited body gestures and other stuff that they can do. And so that's one thing that we hope the model will learn, and it does. Furthermore, it doesn't even see what body movements are being done. Because we calculate the optical flow, it just knows that much movement has been done in this frame. It doesn't know if it's from here to here or from here to there or like a circle. Like it just doesn't know.
Yeah. It's a binary.
Which helps generalize.
Yeah, binary yes or no decision. Yeah, Shabavi, please go ahead.
Amit has just answered it. So I was asking that it is not basically being recognized. It is just detection. So if even I start moving my hands, not in any particular sign language, it will detect as signing, right?
So yes, like it would detect signing for other movements. I see that we have this question also in the chat right now. Yes, so for other movements like scratching your face, it might detect that, it might not. For like swiveling in the chair, it might detect that or not. This is like something that we'll have to deal with. especially where some of these other movements, so just doing like this, hello, like I don't know if like zoom, yeah, hello. This can be a gesture that I'm just doing, or this can be sign language. Also, this scratching my face can be scratching my face or could be sign language. You just don't know. So it's somewhat good to, in my opinion, to err on the side of false positives rather than having like false negatives, um, because we can actually deal with, if like you had like one peak of signing for a second, that doesn't really disrupt the flow of conversation um, as much as not being detected. Um, but it is something that I think should be researched in the future, like user experience research, to figure out um, how effective this or how sensitive it is to false positives. In the video that I showed you, which is obviously cherry picked by me being human, but it's just like a video that I asked my friend to record. I didn't do any edits to it. We can see that it manages to capture her signing really well, but she doesn't have distractors there. So she doesn't scratch her head. If she did, we could see, for example, that it might catch or might not catch it, or it might just have like a small bump in detection, and then it continues to work just fine. Does that answer your question?
Yeah, Shambhavi?
Yes, it answers mine.
Also, is there a way, let's say, scratching your head, that's like an activity detection, right? That is not
Mhm.
just sign language, it's an activity detection. So, is there any possibility to combine, let's say you have a data set where you have certain activities. Let's say you have a, for hypothetical sake, you have a data set of scratching your head and you
Mhm.
have a sign language data set. Is it possible to combine them so that we can remove that activity that will come into like a recognition kind of
Yeah, 100%. So it is possible to get some sort of recognition in the system. It is just that one thing that we need to think about is if, for example, scratching your head is not an activity that we would like to detect, that's something that we only know after the scratching has been done, kind of thing. So if I move my hand to my face, that might be because I'm starting to sign, or it might be because I want to scratch my face. We want to detect as soon as possible that you are starting to sign, because otherwise maybe the in the application will miss some of your signing. And so we just really care about the strong movements and this sequences of movements. And in the future, for something like, I don't know, sign language translation, one can think of maybe we should also combine it with other gestures that are common, like scratching your face or picking your nose or I don't know what, and try to suppress these in the recognition part. If they come alone, and we don't want to say like I'm doing this, and it just writes pink in the bottom. Like that's not going to be very good user experience.
understood. Very good. Thank you. We have one more question by Geetanjali.
Yeah,
You can
please.
unmute yourself and go ahead, Geetanjali, if you want. Okay.
Yeah, so I'll read the
I
question,
think
I
it's a
guess.
closed captioning I get.
Yeah, I had seen a paper which automatically generates subtitles in the movie from lip movements. Maybe this could improve the model. Uh, yes, so lip movements, so like models like LipNet and others, uh, they can indeed like transcribe um, like text or transcribe like spoken language from the lip movement. There is some areas where this kind of works or not. So there are some sounds that look the same in the mouth. I think like B and P or F and V, like F and V. Um, but generally, these models work.
Yeah, and that is not the
The
focus. The focus of your work is detection.
Yeah,
That is what
but
I.
talking about the actual like translation, which is a really good and important direction. Um, the person who is signing does not mouth what they are signing. They're not like they can. They don't always do that. Um, Sometimes like it's not even a part of what they are signing, or there isn't a specific word in a matching language to actually mouth. So that's one thing to consider. And I guess that future work needs to look at the lips as well as the entire rest of the body in order to understand the signing. Like the lips could be a good feature, but they also could just mean nothing. So we need to be careful about using something like that comes from like audible languages, like lip movement of like speaking the words in order to detect sign language, because they are different.
Okay. I think Gitanjali, does that answer your question? Okay, we have one more question from Rahul.
Yeah.
If you can quickly take it. Yeah.
Yeah, so normal frame classification is option to have better recognition over optical flow best model. So frame classification might work, but we have to be careful there, as the frames, they have a few like pitfalls. So one pitfall is, what if the model that needs to like kind of encode the frame or encode each frame is quite heavy? So if you use like a ResNet type model, that's not going to fly on mobile devices or maybe on even desktop devices. Second, if you have movement in the background, then that might trigger some things in the frame classification model that we don't necessarily want. If the person is moving in a certain way that isn't signing, that's also something that we don't necessarily want. And in order to be very, very inclusive to everyone, so you want a model to work well on white people, on black people, on Asians, on like everyone, men, women, etc., then having this like frame-based model is quite dangerous, like ethically speaking, because it might just work well on one group of people, but not as well on a minority of people. And that's why using the optical flow of just like a certain set of landmarks on the body, in my opinion, is better and more inclusive to everyone. I hope this answers your question.
Rahul, does that answer your question? You can unmute yourself and go ahead if you. Okay. Yes, it does answer.
Yeah. Okay.
Thank you.
Perfect.
Yeah. Please go ahead. Yeah.
Thank you. Yeah. So in order to actually do this like application side for the audio transmission, we first had to consider what audio are we gonna pass through. So we are getting ultrasonic audio, which is roughly 20,000 frames, 20,000 hertz or higher. This audio cannot be heard by humans, but it can be heard by dogs, cats, and other pets. If we go higher, we might risk the compression algorithm of the audio to corrupt our audio. And doesn't matter because we have like a limit that we can transmit. And cockroaches, for example, can hear up to 60K hertz. So we can't go even higher than that. For consumer audio devices, so like my headphones and my microphone, etc., they, as far as we checked, cannot really generate audio at 20K hertz. It's too high frequency for it to generate. Some devices might generate it like as a lower or corrupted audio, but most just wouldn't generate it, which then makes it really muted, like you can't hear anything. To do this, like we're kind of controlling the microphone in like video chat. We don't even control the headset. We control the microphone, which is not something one normally can do. But to do that, we use something called virtual audio cable, which is a fake or virtual microphone and a fake or virtual speaker, that everything that goes in the speaker, like in one hand, goes through the microphone. So it's like a channel where you can transmit audio. And people like have to choose this in their video conferencing software. One downside that it has is that we're using virtual audio cables for Mac and Windows, but we also want to support everybody, right? We want to support every device. We're now working on this is a public project for a virtual audio controller or a cable for Google Chrome. So it's like an extension that instead of installing this software on the computer, you could just install the extension, and that would work. It would just add audio to your microphone and you could use it in any device that has Google Chrome or Firefox for that matters. Hopefully we'll get that out pretty soon. And yeah, I want to like conclude with like a positive statement of saying that video conferencing applications should be accessible to everyone. It is not the case right now. Signers currently have their tricks on how to deal with Zoom and Google Meet, and it's quite funny and interesting to hear what every group of signing does in order to get attention, in order to like see everybody, in order to have like a webinar style conversation. It depends really on the group of people that are doing this. And this doesn't have to be this way. We could have this kind of feature in all applications, and maybe this doesn't make all applications as usable or as accessible to signers and deaf people like it is accessible to all hearing people. But it's a step, right? Because this is the first step. Second step could be sign language detection or recognition or translation, UI changes, etc., that just can benefit people. But we had to make the first step in order for people to adopt this and actually take this to the next level. We have some future works that we're planning on, which are one, we want to use like a better and faster pose estimation system. Right now we're using TFJS in the browser. It's quite fast, but on some devices it can like get to 16 FPS, which is not as fast as one would hope. And that's okay. Like we can get a faster pose estimation. We also want to get the pose estimation for the hands. Right now we only use the body pose estimation in our application, but we saw that using hands as well gets 1% over the body. So why not also use the hands? That would be a good idea. We want to keep like researching the sign language detection area. So as we said, like there are a lot of distractors that could be removed and should be. And we did get some feedback from people saying, like, I don't want to get detected when I pick my nose or when I scratch my face or when I eat. So for examples, when someone eats, they can mute themselves, right? That's totally fine, and that's what I do as a speaker, hearing speaker. Or when I make side conversations, if someone just goes in my room and I talk to them, I mute myself. And signers say like I don't want to be detected when I'm signing, and that's okay. Like we could have mute options, but for the model itself, it is better if it can capture some more distractors and get higher accuracy. Right now, we only support desktop devices with our application, which is cool and fine, but people use mobile. So we're looking into how we can get this into mobile devices as well. It's quite harder because there is no available access to the microphone to control what the microphone does, but it is something that we're thinking on. And the last thing that we're thinking on is also to work on sign language recognition and translation. So if someone is making a sign that can be detected, that could be shown, or a sequence of signs. Or maybe also we could start with finger spelling, for example. If someone is finger spelling something and it's quite fast and the video quality wasn't quite good, there could be some kind of finger spelling detection model that just says what someone spelled. That's first steps towards, or small steps towards getting better and better models. That's like the general idea of what we're aiming for. And yeah, I want to thank you for listening and having this opportunity to talk about my work. And yeah, I can see some question in the chat.
Yeah. Thank you, Amit. Thank you very much. We'll have just few quick questions. You can go ahead. Pierre, you can go unmute yourself and go ahead if you want.
Yeah, and please, if you have any other questions, chat them or talk about them.
Right.
Okay.
Yeah, so I'll go through the first question. Since your application generates noise that is picked up by a virtual microphone, wouldn't muting yourself also allow you to eat without being picked up as signing? Yes, that's true. So right now, this is something somewhat of a concern that like signers have because they don't normally use the mute functionality, they might just mute themselves in the beginning of a conversation and then never unmute themselves because they won't talk. But this is like some kind of a behavior change that could happen once this kind of models exist. When this model exists, we want them to not mute themselves. We want them to be unmuted. And once they want to be muted, that's totally fine. They can like press, there are keyboard shortcuts, or they could just press the mute button, and that would solve it for them. It's
Right.
somewhat of an education matter rather than functionality.
Right.
But thanks for the
So,
question.
yeah, can I go ahead?
Please, yeah.
Okay, right. So I wanted to ask a few things. One would be, if I am trying to create somewhat like open data set for Indian Sign Language, would it be a good idea to go ahead with just the gestures initially, or a better way is to include all the facial expressions and everything? How do the researchers prefer the data set to be?
That's a good question. It somewhat depends on the, I think, scope that you're aiming for. So if you're aiming for a general, like conversational sign language data set, that means like everything, then it would very much be useful to have both the manual, so hands features, and the non-manual, so face and body features, like leaning forward, leaning backwards, saying, for example, on one side this, on the other side that, moving the body is important.
Also.
But there are data sets that I'm aware of that just use like a small subset of signs, and
Right.
so they can like detect or only annotate the parts that matter for these signs. I personally would love seeing like annotation of everything, meaning like the facial expression, the hands movement, the hand shape, the location, etc. Like these are really important features for the translation.
Okay.
And I would like say that you should take a look into a system called sign writing, which is
Okay.
one way to annotate or to write down a video in sign language, but you write it in as text, or like as like a drawing where there are a specific number of tokens, and it's a very established way to write sign language and then annotate it.
Amit, thank you very much. If possible, can you just show us in the browser what we're talking about, sign writing, if possible?
Yes, sure.
Yeah.
So sign writing.
Okay, okay.
Yeah,
Oh,
okay.
okay. So what do
So
we do?
So one sec. Let's see if we have some signs here in the video. Yeah, so for example, right now he's holding his hand in a specific shape. So
Yeah.
he's writing down the hand shape. And there are many hand shapes to write.
Oh,
If we go to something,
it's like labeling, right? This is like labeling.
this is like writing down the sign language as a sort of
Okay,
text. I'm trying to find if there is a,
okay.
so there is a dictionary in American Sign Language, or let's go to the writing system. So American English, let's see, US.
Others, please put your questions in the chat. We have Amit can take some more questions. Okay.
Yeah. Yeah. So for example, this is a labeling, right? They're saying the text here, the English counterpart is cemetery, but instead of showing you a video of cemetery, they're showing the two hand
Symbol.
shapes.
Oh,
So one hand shape, like both hand shapes are like this, so open hands.
Yeah.
But one hand shape seems like it's towards the person, so the black hand shape is towards the person, and the white hand shape is other way around. So it's like somewhat like
Oh,
this.
understood.
And there is movement patterns, and this is also a hand shape. So it actually goes from the bottom to the top one.
Oh,
I wouldn't specifically know how to sign this,
Right.
but this is a system that you don't have to write the face one, for example, for this one, because there isn't face for this one. Or this is how you do sand, or cup, or
Yeah, and this is not standardized, right? This is specific to like, let's say we use it and we write our own symbol, or is this standard symbol?
these are standard symbols. So
Okay.
so there is actually in this website there is a system to write this
Mm-hmm.
kind of thing. So
Mm-hmm.
I'm not sure if it's here or not. I might I can shoot you
Yeah,
after
yeah.
the talk.
Sure, sure,
But
sure.
there is a way to write these, and there is a set of symbols for every hand shape. There is a symbol for how it oriented in space, for every movement, for every type of movement, for every facial expression, touching in any location. These are all annotated. So these are all, sorry, defined. It's a well-defined system for like I think 40 years now. It's being researched.
Ooh,
This
very good.
specific writing system. So that would be one way to annotate kind of everything in a more recognized system rather than writing something of your own.
Yeah, yeah.
Um, yeah, so there's, yeah, I think software would.
Good, good. Very good, Amit. Yeah.
Yeah, anyway,
Shambhavi?
yeah.
Yeah.
Yes. So one more question again regarding the data set, because that is where right now I'm stuck with.
Mhm.
If we are trying to record a data set on sign language, do we prefer different people signing the same signs, or shall I just go with one video of one sign and do the padding and repetition stuff and create the data set like that? What is the benefit of different people signing the same sign, and how can I exploit it?
So the benefit I see in having multiple people signing the same sign um, is there are many. One is to have kind of like a variety or somewhat of a standard deviation in the movement. So I sign hello like this, like hello, but someone might sign it like this, like a bit farther there or to the top, up above. That shows you like you can. That shows you that multiple people can sign the same sign, but in a slightly different manner. The writing system might be pretty much the
Right.
same, um, or the annotation, but you still need to get from having any kind of person to writing them, also or to detecting them, to
Right.
recognizing them. It is also good that you have men and women, right? Because that signing might be different. It's been shown, although very in a very small group right now, that that gay people, at least in Israeli sign language, gay people have kind of a different way of signing. They have a more open and more bigger signing, which is important to capture as well in your data set. And if you have just one video per sign, that might not always catch it. Um, in my opinion, if you want the data set to be useful right now for research, have multiple videos per sign by like multiple people and even multiple angles, right? So if you have um, like a room where you set up cameras, you could set up 5 cameras at 5 different angles and
Right.
capture the videos. Um, that would be more useful for research right now because it means that you can have some scene signs in the training set and some scene sign in the test sets. But I think in the future, as we grow and we learn more about how to generally look at some sign or look at some video and annotate it or write it down, then that might just make more sense to have one video per sign or lower number of videos per more signs.
Yeah,
Thank you so
Rahul.
much for the insight about the gender thing. I didn't know at all. I would really like to read more on this.
Yeah, I might be able to send you something if it's public already.
Yes, yes.
I'll try to see if this is public. Yeah, it's not like the main issue, but it is something that
Good to
I
include.
wouldn't like to
Yes,
have
mind-blowing
right now.
feature.
Yeah,
Mm.
to include more. Exactly.
Rahul has a question. Are there any other options for detection of sign language? Rahul, can you expand the question, if possible? Hello, Rahul. Okay. What do
Um,
you? Yeah.
so for detection of sign language, so this is like the work that I presented now.
Yeah.
options might be like you previously mentioned, to have like a per frame model, or to look directly at the images, or to use some kind of pattern matching system. For sign language recognition, so if you want like to see a video of a single sign, for example, and have it written down, or a phrase and just write down the signs, right now there aren't like good systems that do this. There is research on some closed domain data sets, like weather data sets, where you can see it being done. And I see that you write other options for detection of sign language, like pose estimation, hand detection, etc. So if you're talking about the way to like annotate data,
yeah, annotation is the issue here, maybe. Yeah.
So maybe like you're saying pose estimation, which is good. Hand detection is good, but also maybe depth information might help in academic scenarios, but not in the real world, because the cameras don't really have depth sensors right now. Yeah, but other than that, I think that like these are the main options. So having either the frame, pose estimation, or detection.
Yeah. Rahul, does that answer your question, or was that what you were asking? Okay. Yeah. So Gitanjali has one more. You can just read it.
Yeah. So the idea of generating virtual audio or virtual sound is really exceptional. Maybe in next 10 years, we will be able to generate artificial voice for sign language instead of ultrasonic sound. Thank you. Oh, yes. So thank you so much. This is like, I think one of the exceptional ideas, right? To have signers sign, and then that being automatically being translated to audio. This is somewhat like similar to if you read, I don't know, the Hitchhiker's Guide to the Galaxy. They have like a fish where they put in the ear, and then the fish translates every language to your language.
Yes.
And I think that this doesn't have to be like only this direction. This could be both directions, meaning that if I would like to hear someone rather than see them sign, or see them but also hear them, then I think that I should be able to do that. Same for signers. If they want to see me sign, or to see someone signs what I'm speaking, that's perfectly reasonable. It might be a bit politically incorrect to have signers like spoken over. But in order to have a real conversation, you need to understand what the signer says. So either by writing what they're signing, or saying this, you're getting away from the sign language anyway. So I think this is like okay and good.
Yeah. I think you are focusing on video conference. That's why you are giving that ultrasound blast, no? Because your focus is
Yeah. So I think his question is also about like when having a meeting, right? You want to be able to know what everyone is saying, and generally this like ultrasonic audio is just a hack, right? We just wanted to make it work in platforms, instead of me needing to, like, I don't know, find someone at Zoom and tell them, hey, can you please like make this work? Thank you.
Yeah. One more question, probably the last one from me. Not very serious one though. People have been coming up with very interesting names for the papers, right? Attention is all you need and all that stuff. So I guess 20 kilohertz was the frequency at which bats speak. Bats.
Really?
Right? Yeah. So did you ever thought about naming a paper in an interesting way? Something like, now bats will help you.
I did not know that bats like speak in this kind of frequency. This would have been cool. I gotta say. If this was a project I did like at university rather than at Google, I would definitely try to come up with a funnier name. That's for sure. Yeah, so like
one in
this could be a really funny, like a funny
Yeah,
name.
yeah.
Yeah.
In the wild, I think they converse at a different frequency.
Mhm.
Yeah, maybe.
Yes.
I just had one question. The table, Amit, where
Yeah.
you have the different models and where you're comparing
Mhm.
inference time, maybe. Yeah,
Yep.
yeah. Here, let's say you wanted to continue the work and try a different model. So, what are similar models similar to pose all, or is it a good exercise to have, let's say, I have pose hands? Is it a good exercise to compare it with other models similar to pose hands where you have only hand information available?
Um, yeah, I believe so. So like if you want to compare something,
Different thing.
I would
Yeah.
first like always try to compare to the like best model having everything, all of the features. So just saying
Mhm,
like
mhm,
maybe this is somewhat of an upper bound, like in a
mhm,
sense, in a conceptual thing sense.
mhm,
So for example, if I had the pose hands here model score
mhm,
higher than the
mhm,
pose all model, I would be
mhm.
very suspicious. Uh,
Okay.
but
Yeah, yeah.
comparing just the hands model, so if you, for example, just cropped hands
Mhm,
and then had them like as image features go in to like a
mhm,
whatever kind of network,
mhm,
then it would be good to say, okay, we surpass the previous work by just doing this,
mhm.
like compared to these 88% rather than compared to the 91%. Right? That's
Yeah,
my
yeah.
feeling.
There's one question related to this table from Pierre.
Mhm.
Yeah. You,
Regarding this table, the results for the hands is surprising compared to the full body since the heat map shows clear correlation between hand movement and signing. Did you try to look more into what could justify this? Yes. So if we look at the heat map here, the the hands do seem like very good correlation to the signing annotation, but maybe they are like bluer or stronger here because hands move normally more than the rest of your body. So your shoulder will move like less in frames, I guess. And so the magnitude of movement is different between the body and the hands. If we somehow normalized the magnitude, I'm confident that the body, or at least the wrists of the hand, would show up a very like good movement, but definitely not as much movement as the hands themselves. This doesn't mean that we rely like on how much everything moved altogether. We rely on the movement of every part independently. So the model can learn coefficients for every movement. So for the wrist, for the elbow, for the shoulder, and then use that. Um, and then Raul asks, why PyTorch is faster than TensorFlow? And this is back to this table. I do not know. I would assume, like I can make multiple assumptions. The first being that in order to get the TensorFlow to like run, it has some like backbone, like some kind of like a pre-start process that it has to do, and PyTorch is faster by doing that. I believe that the TensorFlow model could be optimized like more, for sure. It's just that the PyTorch model, um, by being PyTorch, it just does like the matrix multiplications. It doesn't right now get up like an environment and set up variables and whatever. This is just me multiplying stuff. And here in TensorFlow, it's me saying TensorFlow model.predict. And who knows what predict does other than the matrix multiplications. Sorry.
yeah. Pierre, I hope that answers your question. And Rahul, if you have a follow up, you can go ahead. When you say, I just had two questions. When you
Mm-hmm.
say single frame, if you use single frame for detection,
Mm-hmm.
obviously, let's say you have 60 frames per second, videos being recorded, or a conference, I don't know what was the frame per second for a conference. A single frame may not be able to detect it, right? The whether the sign is being made or not. It is
Yeah.
too, yeah.
So a single frame would be like freezing in space,
Yeah,
right?
yeah,
You
yeah,
don't
yeah.
know what happens.
Yes, yes.
Here in linear one, for example, we
Mm-hmm.
don't use a single frame. We use a like a two frame window. So we just use
Mm-hmm.
an optical flow, a single one, from two adjacent frames. And so we know only like what movement happens.
Let's say you have 10 frames. How would linear one go about processing them?
So for example, 10 frames, if we have two of them, then you have this second MLP, it looks at the optical flow of the current frame and the previous one. But if you had 5, then this last one would look at this optical flow as well as this one, and that one. Like it would somehow like have this information inside, and that's why higher like linear models use more parameters because they just have more history.
So there's no skipping. Every frame is taken into consideration.
Yep. Yep.
Oh, okay.
This makes the model faster to react, right? Because you're starting to sign, and if the model catches you after 500 milliseconds, that might not be enough to have a meaningful conversation. And if you have a model catch you like after a single frame or 2 frames, that's quite better.
And I had one last question. Let's say we stack all of them, detection, recognition, translation together. Will it be pretty heavy to be deployed for real-time systems? Is there a constraint?
So it depends. So if you say, for example, recognition in a real-time manner, if you do recognition, for example, in a just a streamed way, so you have a model that has a left to right kind of model inside of it, it might not or underperform other models that have like bidirectional information or attention, like of all of the previous states. So that's one consideration to think about. If you just have the, I don't know, recognition model, but it is left to right streamed, then that, I think, could still be used in a real-time application, but maybe requires like not a phone, but maybe a computer, like a desktop computer, or maybe it requires you on the desktop to have the simplest GPU, but a GPU, because right now this runs on CPU, and recognition might be a lot heavier, especially if you will decide to use bidirectional models or attention models, where you have to wait until the end and then do all this calculation, and it's heavy.
Yeah, what do you mean by left to right stream? Just a video or?
So for example, here, not here, here, we get one frame at a time, right? So we have like an LSTM that goes from left to right.
Oh,
so,
okay.
But
Got it.
we're not aware of this state here because that's the future. We can't know the future without seeing the future first.
Yeah. Very good. Very
not
good.
Yet. Future work, predict the future.
And the data set doesn't matter here, right? Like let's say you did it for Brazilian sign language, the same approach. The data set is irrelevant in this case.
I think so, especially because the optical flow, again, it's just like a very fancy movement detector. In a sense, it's like it tries to detect movement patterns, and it doesn't care about directionality. It doesn't specifically care about the language, meaning that it's trained right now on German Sign Language, and we checked it on American Sign Language, and it works phenomenally. So it's like that, yeah.
Got it. Excellent presentation, Amit.
Thank you very much. Thank you for hosting me.
Yeah. It was really very informative. Thank you everyone for joining in. Thank you, Ashwin. Yeah, you can look at the chat if people left the message.
Yeah, thank you very much.
Yeah. And we hope to see more papers from you in the future, Amit.
Thank you.
All the very best for your work. Shambhavi?
Hopefully.
Yeah, nothing. Thank you so much. It was very good. The session was great. I hope your experience was good too. You've tried.
Thank you. Yeah, it's been a pleasure.
Right.
And I hope to see your data set soon.
Yeah, I am taking it quite seriously now after the session today. I really want to probably in 1 year work on a concrete data set for ISL also, now that you pointed out that nothing is out there in open. So yes, that could be a really good work to be carried forward.
Mhm.
And I hope your experience was good too, like not like ECCV where everyone was complaining that there was no one in the post session.
Yeah, same for me. I just opened the Zoom session and then I just coded in the meantime.
Right, right.
Also, Amit, before we let you go ahead, one last question. Were there anything specific asked by the reviewers? Or was there anything that you can remember that
Yeah.
was really touched upon? Yeah.
So there is one specific thing that came from the reviewers, which was there is a previous work about sign language detection. So it's like a Boring and Camilleri data set here. Did you compare to them? So they have a different data set of like sign language in the wild kind of thing. We didn't compare for two reasons that I can think of, but it is a good question to come from like reviewers. Like this exists. You did mention it in your previous work, but why didn't you compare? Their models are like offline, so they use a context window. So they use the future. They use the future, not only the past.
Understood.
They use like
Got
5
it.
frames per second, which skews the accuracy. And yeah, generally it's a different kind of task to detect it in real time rather than in a ready video.
Okay. And before we can think of just one last question before I let you go.
Please.
So obviously you also review lots of papers in this area. So what are the key points that you're looking for when you are reviewing paper in sign language detection or recognition? What do you look for and what is it? Yeah.
So if by like reviewing you mean peer review, like I haven't done any peer review on sign language detection or recognition yet. But like if you mean like just literature review,
yes.
By literature review I just look for I look for works that are respectful of the of like the people using the language. So it's not just another task to do, because if you treat it just as another task to do, you might not understand the pitfalls of everything that you do. And yeah, generally that's that to look at how people treat the language. If they treat it as a language, then I'll be happy normally to read the paper because they'll understand the problems that as a language has. And if they treat it as an action recognition model, like for like sign recognition, that's not good enough because that's not it. Not in my opinion.
Thank you, everyone. I think we'll let Amit go now. Thank you for your time.
Awesome.
It was really incredible presentation.
Thank you so much for inviting me. Have a great one, everybody.
Yeah, you too.